Hello, this is a continuation of video number 2, also known as video number 3. And we're still talking about computer hardware, so I didn't erase that. I had to get rid of the picture to have room. And also I had to make a little set of notes, marginal notes up there to myself so I could remember what we had numbered these things. We've already talked about input devices, check. We have already talked about output devices, check. So we've got pretty much the straightforward, simple ones out of the way. Let's dig into the ones that are slightly more complicated, shall we? To the CPU. Alphabet soup. There are acronyms flying around all over the place in computing. Get used to it. Most of them are not that big a deal. It's just until you look it up online, you're probably not going to know what they're talking about. You know this one, though. This is Central Processing Unit. Central Processing Unit, the CPU. Some people call that big box of a desktop, that thing the CPU. It's got the CPU inside it, but the CPU is actually a little thing, what is it about the size of? Bigger than a postage stamp, unless it's a big postage stamp. But it's a chip that's actually embedded on a board inside that big box that sits on your desktop. There you go. This, I'm going to break this down. This consists of yada, yada, yada. This is numbering system. This is number 2. So I'm going to use ABCs. A is the ALU. Oh, boy, did I ever break the seal on acronyms. Here they come. ALU is short for Arithmetic Logic Unit. A-R-I-T-H-M-E-T-I-C. Arithmetic Logic Unit. The arithmetic logic unit, I'm going to use non-computer speak. Man or woman on the street speak here. Arithmetic logic unit, I'm going to call that the thinking part of the computer. What's it thinking about? It's thinking about, well, is this number bigger than that one? Are those two numbers the same? Is this number positive? Is this number negative? I can add those two numbers together. It's actually thinking very simple thoughts. It just does them millions and millions and millions at a time. Well, not at a time. Whoops. In a row really fast. That's what I meant. It's not doing all of them together at the same time. It does a whole bunch of really, really simple stuff really, really fast. It's actually doing the processing. That's the verb stuff that I talked about that the program instructions tell the computer about. So it can do all that stuff. But what other components could we possibly need in a CPU? We need a control unit. Control unit tells the ALU what to do next. The control unit, that's who I'm talking about now. Control unit tells the ALU what to do next. And as we did with input-output devices, I'm going to do this by example. For example, somewhere in the program it says, get this number from memory. Control unit speaking to ALU here, get that number from memory. And hang on to that for just a microsecond. Get that number, another number. Get that number from memory. I'm making this up as I go along. Okay, you've got two numbers now. Yay, good for you, ALU. Add them up. Add them together. Emphasize add. Put the answer in memory. I guess put as the operative word there. And I'll put some dots. That doesn't sound very complicated at all. It's not. The ALU can't do very complicated things at all. Aww. Just real simple stuff. It can go to memory and get that number. Yeah, anybody could do that. It can go to a different place in memory and get a different number. Now that it's got those two numbers, it can add them together. Now that it's got the sum, it can put that answer back out in memory. The control unit has to have infinite patience with the ALU because it can only do those tiny little baby operations one at a time. My internal metaphor, the one that I explain things to myself, says the control unit is the wedding planner. The control unit is the one that calls the shots, decides which line of the program we're going to do next. Okay, let's go over here. Okay, now that line of the program says add those up. Be a good little ALU and add those up. Now the program says put them in this place in memory. So the control unit is the one that's actually going through and looking to see what needs to be done. And then the ALU just sits there and waits for things to be handed to it more or less on a silver platter. Okay, what do you want me to do next? And then it does that. And then it does that over and over and over and over and over. Now, what's missing here, kind of a chicken and egg thing, you might wonder, when I get the number from memory, where does it go? Funny you should ask. The third part of the central processing unit, an essential part, is the registers. Registers, I'm going to have to put quotes on this. This is so non-technical. I'm going to call this a scratch work area. There are not very many of these. Registers, some machines only have 5 registers, only have 5 little pieces of scratch work area. MIPS, the one that's in PlayStations, that has 32, which is a pretty big number of registers. We don't get much more than that. Each register, reg for short, holds one number. More than 1 bit, thank goodness, but the representation of one number or one letter. One thing, in other words. Or one, I'll even write thing, very generic. One thing. So what was I talking about, chicken and egg? Well, when I get this number from memory, remember memory was a separate box, that's box number 3, we haven't gotten there yet. When it gets that from memory, to put it in some place so the ALU can see it, when we give it an instruction, the control unit says, this is the instruction, I want you to add these 2 things up, and here they are. One of them is in register A, one of them is in register B. Or maybe register 9 and register 17. So I'm going to go back with a different color and say, get this number from memory into R3, register number 3. I'm going back and changing it. Get that number from memory into, how about register 0? Why not? They're generally called general purpose registers. A number will fit in any one of them. The registers, with respect to each other, none of them has any magic superpower or anything. They're all just vanilla. They're all the same. They can all hold the same kind of stuff. It's just whichever one is handy, whichever one is not being used for something else right now. For example, if I got the first number in register 3, I don't want to put the second number in register 3. There's only room for one thing. So if I'm going to add the 2 numbers, one of them's going to go in one register, one of them's going to go in the other register. What about the answer? Add them together into register 2, because we're not using register 2. Then put the answer from register 2 back out to memory. Now it makes sense. Here's a fig. A fig of registers. Here they are. I'm going to pretend like this is a 1, 2, 3, 4, 5. Those are all the same size. Your eyes deceive you. It's an optical illusion. This is register 0, register 1, register 2, register 3, register 4. What's that fig for? To go back and kind of tie this stuff together. Now that I've got these hardware pieces for the CPU, all of this was just for the CPU. Let's say floating around out here in memory somewhere that the control unit knows about, it's got to grab, a 12. 12 out here in memory. This light blue, I hope you can see it. Yeah, that's a 12. Ooh, it's floating around out there in memory. Here is a 6 floating around also out in memory. Whoa, and here's an unused memory location. I'll put a question mark there. Doesn't have anything but garbage in it yet. We might put something in it later. So now we can go through this and actually see what will happen. Get this number. Which number? The number, the first one that I wrote down. Get that from memory into register 3. Yes, ma'am, Miss Control Unit. Here it comes. 12 goes into register 3 right here. Ding. That is one whole operation. At the lowest level, that's the kind of operation it does. Just one tiny little simple thing. Get the number, this other number, get that number, not this one. Get that one from memory into register 0. Here it is. Add them together into register 2. Let's see, 6 plus 12, even I can do that. That's 18. That goes into register 2. Put the answer back out in memory. Overwrite the garbage with an 18. Done and done. Happened in a microsecond. That's just it. What gives the computer the power, what gives the CPU the power, is that even though it's only doing these ridiculously simple little operations, the most complicated one probably is addition. And of all the operations that it's capable of doing, it does them so fast, in tiny little milliseconds, microseconds. It does them so fast that when you put them all together, it can do some really complicated stuff on a grand scale. So here's an example of how all these different pieces of the CPU work together. I get to scratch off the CPU, and my guess is I was so verbose in that description of the CPU that I'm going to have to use yet another video to finally, mercifully get around to memory and long-term storage. I'm having a lot of trouble holding on to stuff. I do think my caffeine is kicking in though, so watch out for the next video. We're actually going to finish up the hardware. Won't that be fun? I'll see you online.